Okay, today we're gonna use largest regression using general social survey. Last week, you used linear regression using Georgia survey, but general social survey is much bigger and more interesting survey. So let me show you how to see code book. If you click here, original code book, you will see there are so many questions, including Snapchat user. It simply asks whether you're using Snapchat or not, whether you're using WhatsApp or not, Google Social, Network, Pinterest. There's so many interesting questions. So this week, using logistic regression, we want to predict who's using Snapchat, who's using Pinterest. Whatever question you are interested in, you can ask. There are so many questions here. So you can use a code book and you can use a CSV file I posted and you can find the right question. Or if you have SPSS, I believe any GSU student can access SPSS. So if you use SPSS, open the file I posted, or if you go GSS website, download the recent file, you will see there's so many questions about so many age of respondents or some other question you can easily find. So I want to review all this list and hope you find something you're interested in and predict with some other variables you select. So let me go back to my one and I want to show you how I did this project. Okay, this is how I did. I'm interested in how IT impact on society. And there's a lot of debating about what is the impact of information technology on society. And some people said IT will continue doing a lot more harm than good. I'd love to know who may say this or who may say different, a positive one. So what I decide to do, I find one very interesting question in general social survey, asking about whether you believe IT harm the society or benefit on the society. So I have to decide which factors will predict or determine IT harm benefit. So these are the factors I find it. Race, age, sex, and I'm interested in religion. So I decide to select one variable asking about feelings of a Bible. And I find also one interesting question about next generation. And I also decide to add whether people trust the science too much. So all with this, so let me show you a specific question. Regarding IT benefit and harm, I decide to use the question variable name nano-will that is actually asking a question about benefit of nanotechnology outweigh harmful result. So I decided to use this question representing whether IT benefit harm. Also, I select the Bible. The question was feelings about the Bible. Second one, next generation, science and technology give more opportunity to the next generation. And then I add one more, trust the science. We trust too much in science. Okay, response values. As you can see here, in terms of race, there's white, black, and other, and over 70% is white. Yeah. In terms of age, mean is 48, median 48, mean 48.97. So minimum 18, maximum 89. I also see the gender, male and female, 44%, 55%. And feelings about Bible, there's 3 different answers. and actually 4 including other. So some people believe the Bible is the word of God. Some people believe it's the inspired word. Some people believe book of fables. I thought this may be interesting question. Predict whether people believe IT benefit or harm. I also use science and technology. You simply ask whether you believe technology and science give more opportunity to next generation. Strongly agree, agree, disagree, strongly disagree kind of response. And then I have also used we trust too much in science, strongly agree to strongly disagree. As you can see, each question has different answer, a range and different range. What I need to do, I need to transform data first. So this is what I do. After I download data, after I select this variable, I decide to transform data. For example, technology benefit question. If you look at the original one, as you can see, it is always from strongly agree to strongly disagree. So I decide to go with anything with the benefit. I said the benefit. Other, I decide to go harm. So benefit or not. In terms of age, I may use all different age, but instead I decide to divide to 2 groups. Anybody younger than 48, I decide to call young. Anybody over 48, I decide to call old. Why? 48 is median. And I also did for the whether we trust too much. Anybody less than 3, I decide to use too much, over not too much. And in terms of race, white is the one, all other, I decide other. So if CS2, so C2 equal 1, so white, I decide to go white, otherwise other. Opportunity or not. If answer is greater than 2, I decide to go opportunity, otherwise no opportunity. So I transform majority of variables. After that, I'm gonna show you soon with the RapidMiner, I test it. I select attribute, I select the role. So my target variable is whether technology benefit or not. And I use the largest regression, and I will show the screen soon, but I can see Bible is a very important factor. It's the significant, your gender is also significant. And I also do create a confusion matrix. I can easily see my confusion matrix accuracy is around the 71.43%. True benefit is around the 91%. And for the class precision, I can see around the 74%. I hope you review my lecture note about confusion matrix. Also, based on this one, I decide title of this project, the impact of feelings about the Bible and information technology, the case of nanotechnology in the 2018 General Social Survey. So now, let's go to RapidMiner together, and let's do this project quickly. So I try to do this quickly. So I want to reduce the video recording time. So okay, let me show you my file first. This is what it looks like. When I import the video file, I see race, age, sex, Bible, next generation, trust science. Each variable was the one, each question from the General Social Survey, and my target variable is the tech benefit. So now I'm gonna retrieve my data, and then let me test it. Yeah. Okay, it's good. And then, of course, my case, when I go to data, when I input the data, I let it put this one as a label. If not, you can do. So I'm gonna close this one. So you may select attribute. Well, I want to go all attributes. I'm not gonna select anything. And if you didn't do anything yet about set role, you can go set role and you can decide whatever the target variable. In my case, it's the tag benefit. And you can select label. My case, I already did, so I don't need. So retrieve tag, and then only thing I'm gonna do, I might want to split data. Okay, let's do this one first, and then I'm gonna split. So I'm gonna use the logistic regression. And then I'm gonna connect. I'm gonna see the model. And I might also want to see example. So let's run. So when I run this one, I see some are significant, like next generation, and sex, Viber, and trust science is all significant. Let me go over to model, and I want to modify this. Like I said earlier, I want to use split. Okay, so I want to split the data. So instead of this, I want to split the data. And then based on this one, I try to use apply model. So based on this model, logistic regression, I try to get the model. And then split data right now, I didn't do anything, but I decided to ratio. So for direction going to logistic regression, my one was 70% of data. And data going to apply model for test purpose, I want to go with the 0.3. So let's okay. So 70 among all data, 70% will go to logistic regression, will test. And then 30% data go to apply model, and it will test. So let me show you what it looks like. We can go label, we can go model, so we can test. So we can see result here. So it already tested, predicted based on model. So looks like, let's go by benefit, highest one. So someone like row number 68, we believe this one will believe benefit, and actual result was benefit. Benefit, all right. And then of course here, our prediction was wrong. We thought this person will believe IT has benefit, but this one is a harm. So this is the model. So now I want to go back to here. And then I want to use the performance. So again, performance has so many different types. So you need to select the right one. So in our case, we may use classification or binomial classification, but I want to use just classification here. So I'm going to disconnect this, the label, I'm going to use this one. And then I want to use performance. Of course, if you're interested, you may also connect the model so you can see what model looks like. So let me move this one a little bit. And then I'm going to run here. So earlier, we already see this model, we already see this one, but now we have the performance. Now, I want to look at my accuracy. It is 72%. In terms of true benefit, I see around 89% class recall. In terms of class precision, around 76%. So I'm good at predicting probably benefit, but looks like my harm pretty low, only 28.57%. So I hope you read my lecture note about this accuracy, sensitivity, and specificity. Also, I want to look at class precision and class recall. So we call sensitivity, specificity, but rapid minor using different term, but basically it's the same. So In terms of true benefit, if that's the target variable, we got around 90%, but non-target harm, we got only 28%. If our target variable is harm, it is actually sensitivity is around 28, specificity is around 90%. Okay, I want to go back to this one. One thing I want to do here, instead of using this, I may use cross validation, so I can put this inside the cross validation, and I might use 10-fold, so I may have a more rigorous one. So I'm gonna save this, and I want to do it again with a different approach. Let's go. So I'm not gonna save this one. So let's do this one. This time I want to use this one, tag benefit, and then you can select attribute if you have to select only part of the data, but I'm gonna use it all again, and set role I already did here. When I import data, I don't need to do. Now I'm gonna do this one, multiply. I want to multiply this one. And then earlier I did, but let me repeat one more time. So what I did earlier was I did the logistic regression. And I did apply model. I did performance. Classification here. But this time, instead of just using this operator, I want to use, like we did previously, I want to use cross-validation. So if I use cross-validations, I'm going to copy. Okay, I want to copy this one. I'm going to cut, or instead, I'm going to put here. So I'm going to connect here. I will use logistic regression as my training with that. And then apply model performance. I'm going to cut. I'm going to put here outside. And then I'm going to connect this one. Also, this requires another line for the testing. So I want to use existing data. So I'm going to connect this one. In terms of performance, I need to connect the performance. Be careful here. Example, you can use for testing. So I'm going to go outside and I'm going to connect here. And I want to see model. I might also want to see performance. So when you click this one, you will see my model has around 71.75% with around plus minus 3.79 since I have 10 different tests, 10 folds. So this one looks same, but I just use a cross validation. And then the reason why I using multiply, I want to use something called compare rocks. I hope you can read my lecture note about the performance here. So this one, I just simply want to see logistic regression is the best, or maybe something else, maybe better. So compare rocks will compare different algorithm, and some of them we will do next week. So first, I just did the logistic regression. So I move logistic regression here. I just want to visually compare whether this model is good or something else is better. And then next one, I might want to use something called decision tree. This is what we'll do next week, but I will do. So I want to compare with the logistic regression and decision tree. Also, next week, we're going to talk about KNN. So I want to use KNN. Also, lastly, I want to do something called naive phase. Okay, I want to get out here. connect the rocks, make sure. About this rock, I hope you can read my lecture note, which I posted about measuring performance. Now, let me click the run and see what it looks like. Cross-validation, we already saw, so I don't want to repeat, but compare rocks. In these rocks, we need to see this curve go far away, far above to the left side. But right now, based on our model, green, which is the KNN, is worst, and blue is actually dysentery, is best. About this lecture, I hope, again, read my lecture note. I hope you can review. So I'm done for this one. So based on this one, again, I find out that Bible was the very important factor predicting people's belief about technology benefit or harm. And this is all about this week's lecture, and I will see you next week.